Y por favor, ya está por ahí. Quiero un aplauso muy, muy grande, si son tan amables, para Benjamin Dillenburger. Benjamin, bienvenido, welcome. Thank you very much for being here. Él es un pionero que está transformando la manera en que entendemos y fabricamos la arquitectura en la era digital. Thank you so much, Benjamin. It's an honor to have you here. Thank you for sharing your vision, a vision that truly expands how we think about the future of architecture and construction. I had to say it in English.
Yeah,
It's better than Spanish, right?
Yeah, because then I can understand. Yeah,
Exactly. Thank you very much. Y también queremos agradecerle a la Embajada Suiza en México por hacer posible que estuvieras con nosotros aquí. Thank you very much to the Swiss Embassy. Y por favor, un aplauso enorme para Benjamin. The stage is yours, man.
Thank you.
This is also for you. I'm going to be on this side now.
Hello, welcome. It's really a big pleasure to be able to talk about my work today at this fantastic event. It's a special pleasure to talk after Venora and Carla, two fantastic architects, researchers that I happen to know already from my home base at ETH Zurich in Switzerland. I would like to talk today about design across scales, and I will, in short, explain you what I mean by that. Today, architecture is confronted with new opportunities that also come from, for example, digital technologies that we have available, but also new challenges. And we cannot afford to think of buildings only at the building scale anymore, but we have also the opportunity to think about material systems at the material scales, down to micrometers. But also we have to keep in mind global impact of our actions, of the way how we build architecture. And our research at ETH Zurich focuses on large-scale additive construction, which is very closely related to 2D printing processes. You see here a close-up where we have a method of bringing information to paper, different colors here in the scale of micrometers. And the first big 3D printing machine that we worked with in our research is such a binder jet printer that works very similar. It is 4 by 2 meter print bed and can print natural artificial stone within 24 hours. And what is very special about this machine is that it has a high resolution of 40,000 pixel by 60,000 pixel per layer, and each layer is just 0.2 millimeters high. And for example, this screen here has maybe 2,000 by 1,000 pixels. But this poses an interesting question to us architects. If I might quote now Louis Kahn, you say to a brick, "What do you want, brick?" And brick says to you, "I like an arch." Now the question is for us as architects, what does a grain of sand want to be? And we started with thinking, how can we inform such a huge possibility space when we can materialize almost everything? And we understood that we need new instruments for design. And together with my partner Michael Hansmeyer, we developed algorithms that allow us to explore forms that we could not draw manually anymore, that we could not model in the computer, and that maybe also go beyond our imagination. So these are procedural design routines that allow us to explore a design space of forms that have a porosity, multiple layers, could be microstructures, they can be functional, performative, they can be a pure aesthetic pleasure, and these forms are definitely forms that we cannot fabricate anymore manually. So our first experiences was using this large-scale binder jet printer for printing architecture. And you see here that these machines are really a game changer. When printing this backside of this room is not faster than printing the front side of the Digital Grotesque 1, which was exhibited in the French Architecture Museum in Orléans. So that means for the first time, using these machines that have no precedence in architectural history, complexity turns from a challenge to an opportunity. Here, this is the second variation, Digital Grotesque 2, which is exhibited in Centre Pompidou 2. And you see that our research here explores the limits of what we can design with computers, what we can fabricate with large-scale 3D printers, but also what the material stone can handle. So you see very filigree parts. No masoner in the world could carve this out of stone without breaking it anymore. But that leads us to, after these provocative questions, after these experiments that are really important to understand the nature of the machines and instruments that we are dealing with. We ask ourselves also, how can we scale this up to larger architectural scales? How can we harvest the potential for performative solutions? And what you see is our lab space at ETH, where we have large-scale 3D robotic arms that can help us investigate how we can build in future architecture. And the main principle and the strategy we are following is trying to support the designer already in the design process down to a prefabrication or fabrication with a high degree of automation to create better building components that are more performative, energy saving, but also more heterogeneous. And then also thinking of this life cycle of these elements. This is the little red arrow on the left side. Very important, our research, and I think this is also one of the future trajectories of design and architecture, is to work across disciplines, not only across scales. In our big research program, we work together with roboticists, computer scientists, material scientists, in order to really create an impact on the way we build. First project I wanted to show is a project that is based on the upcycling principle, works that we have seen also from De Nora going in this direction. Here we are dealing with marble waste. Marble quarries produce, everything you see here below is actually marble waste. So up to 30 to 70% of the marble that is carved out of the stone turns into waste. And we thought, can we use the 3D printing method to turn this into new building components? You see here a mobile 3D printer, binder jet printer that we brought on a quarry site where we could work with this local marble waste dust that actually really is a problem for the quarries, what to do with this. This is marble dust from a marble quarry that was actually used for creating the cathedrals in Milano. And you see my researcher Pietro, who developed this machine that is now the same principle as the printer that I showed before, but can print with many different kinds of materials. And in this case, it's marble dust and a geopolymer binder that doesn't use any cement. The final product that you see at the end is a collaboration with my colleague Philip Block, structurally optimized slab system that doesn't require reinforcement, can be prefabricated, assembled and disassembled on the construction site and follows ancient structural principles of compression only. Yeah. And it's dog friendly. With the same technology, we contributed to an exhibition of the architect Osru, his anti-ruin project, also displayed at the Arsenale in Venice, if you still have the chance to see it, where again the concept is investigated how to turn a waste material into new architecture. Another aspect I wanted to show you, which is more of an experimental research, we are on the beginning, is thinking about, okay, what happens if we don't rely entirely on really machines, but also on biology to fabricate architecture. And in this case, the researcher Karen investigates biocementation processes that are similar processes to concrete curing, but based on bacteria. So you have to imagine we have here now not a single 3D printer, but billions of bacteria that help us to create a concrete-like final material with much lower CO2 emissions. And that was also exhibited at the Biennale Venice. It's a project where this robot is set up in a way that he solidifies the earth with the help of the bacteria. This installation is permanently running. So these earth formations start to grow and grow over the next 3 months still. I heard that it's also one of the only exhibitions at the Biennale where the robots are still running. So our technicians are very proud of this. But it's a new way of looking of how could we in future build materials with the help of these little helpers and biological systems. Another idea that we have is, together with Andrea Ling, a PhD researcher from my group, is what happens if we could print with living materials that actually after the printing continue living and add additional behavior and functions to our elements. So this is one of the first 3D prints with a living algae, cyanobacteria, which runs a photosynthetic process after it's printed. That's you can see it well in this green color, which is not there at the beginning. This was a tiny experiment, a couple of centimeters tall. And from Andrea and her research group, the architects group Living Room Collective then scaled up to the pavilion in Canadian Pavilion in the Venice Architecture Biennale. You see here how a potential future of growing these building components could look like. That is basically making these elements ready to be released into the open world. And this was the final exhibition at the Canadian Pavilion. It's still going on. It requires maintenance. So these future building structures requires gardening to maintain, watering, but they actually really bind CO2 with a very similar photosynthetic process as we know from trees. So one of the main research questions for us is always how to scale up 3D printing. What kind of architecture do we derive from 3D printing methods? Here, test how could we print with plastics, for example, to create large spaces composed out of multiple diverse columns. But with plastic printing, usually main challenge is it really hardly scales up. We can scale up maybe layer heights, but then the elements become heavy and hard to handle, and we really waste a lot of plastic material. That's why we developed in our lab a new printing method, which I can show here, based on a student project, our postgraduate program, where architects learn how to specialize in these manufacturing processes as Denora did. And what is special is that we print not only with plastic, but also with air. So we print hollow parts, which allow us to scale up the plastic printing process by factor 10. The resulting components are much lighter. We can use recycled plastic, what you have just seen, to create these ultra lightweight building components, which have a much higher degree of transparency, but we can also color them as done in this installation by the students. It's a hollow extrusion that can range up to 30 millimeter extrusion width. There you see here the final project of the students. That is an ice cream shop in the middle of the mountains, probably one of the highest ice cream shops in Switzerland, but that's only 1,600 meter altitude, so we are here already higher. And you see that we introduce color to Swiss architecture, something we might have learned from the Mexican. Maybe lastly, I wanted to talk about concrete printing, printing with liquid stone. We are not the first ones exploring this. This is considered to be one of the first concrete printing approaches, not digital, with an analog machine that can print in circles. You see it's a very rough layer height, but it already tries to build concrete with less manual labor and without formwork. And this is how this looks like in our lab. I wanted to show you not only success stories, also what it means to develop these methods. The challenge of concrete printing is that the layers have to harden, while the lower layers need to harden to carry the higher layers. And that doesn't always work, as you can see in these experiments. That shows a bit that this concrete printing is almost like cooking or baking process. But we found those experiments also highly aesthetic, and we can learn from these structures that emerge once the material gets its own character and freedom. So these are initial tests. Nowadays we can print much faster, much more reliable, of course, 2 meter or 3 meter tall columns within 2 or 3 hours. And lastly, we got the commission to create a project together with a non-profit organization, Origin Foundation, with the agenda of creating a completely new performance space for cultural activities, but at the same time also revitalizing an old village in the mountains, a village that is about to die out. There's only 12 more people living in this village, Moulins. And the idea is here that we bring in cultural artifact. A lot of buildings are renovated in order to create a possible new future for this village. And that's the Tor Alva project, which consists of 3D printed columns. A lot of research is brought in here, but I will focus on the column aspects. We work with lightweight structures, and we work with multiple hierarchies. So designing not only the overall form, also in between hierarchies that define the individual columns, but also on the surface structures, the ornament of the columns. And we learned this from structures such as this lightweight Mexican cactus, indeed. Yeah. So this is how it looks like. When you see now the larger columns, they are all hollow. They use much less material than we know. We work with a material-driven ornament. So this is not an ornament that we generate with geometry, but with the process itself. So every dripping of this concrete actually is by intention in order to create this a bit uncontrolled ornament. And what is special is that we collaborate with multiple robots in order to not only print the concrete, but also add the reinforcement in the same process. This has to be structurally tested. I wanted to conclude here that these projects should actually show how we not only develop a culture of construction, but how we also can construct new cultures. That project is a collaboration with a lot of local industry partners. The entire community of this village was engaged in this project. We all celebrated together the opening of the tower. And the communication, the exchange with industry partners that learn from this process, that criticized where it didn't work, that are at the end very proud of this project, show it to colleagues, share it, of course, on social media. Seeing that this village now became very attractive, much more people visiting this village now every day is an indicator how we could move towards a digital building culture. So this is now on display. It will be in summer activated as a place for, as a stage for a theater, and in winter as an indoor stage for smaller performances. So working across scales allows us to move from volume to value, from form to performance, and allows us to address also in our design language the multiple scales that are required actually for architecture. I wanted to conclude with a quote from Henry van der Velde, which is a little bit the vision also of our research group, to realize our dream of a material which follows our intentions as easily as the language follows our thoughts. Thank you.
Thank you very much, Benjamin. Amazing.